All right, we got twin because we have a test Friday. What's the equation of a parabola in vertex form that has a vertex at -2, 4 and passes through the point -112? So we've been working on this since August the 8th. Like, it's been a long process. I wish I could help you all memorize, but we're going to plug into y equals a times x minus h squared plus k. I don't know how many times I've written that out for y'all, but it's way too many. That's what it is. It's way too many. So we have a vertex here at -2, 4. That gives us h and k for the umpteenth time. So we're going to plug that in. That's going to give us y equals a times x plus 2, not minus 2, quantity squared, plus 4. Change sign, keep sign. Now, the point over here, off to your right, is going to give you an x and a y value that you can substitute into. I want to say on quiz 2-1 through 2-3, this is about a 30% success rate. So y is the first question. So everywhere I see a y, I'm going to be a 12. And everywhere I see an x, I'm going to be a -1. And we're just going to do some math here, kids. So you can push buttons. If you push buttons, just push buttons on all of this, right? Bless you, but push buttons. You got a -1 plus a 2, which is 1. 1 squared is 1. There is 1a. And then you have the plus 4. Now the 4 is going to get subtracted from 12. That gives us 8. So my a value is 8. Now your goal here, and this will be multiple choice, but your goal is to actually write the equation. So when you talk about your equation, you just have to plug that 8 in where she belongs, and she belongs right there. The equation is y equals 8 times x plus 2 quantity squared plus 4. That's how hard it is. Function g, moving on to the second one. Function g is transformation of another function, x squared. G has been translated to right 3. And something else, down 2. Write an equation for g of x in standard form. So we're going to start with vertex form, and then we're going to work our way from there. Start with vertex form and turn it into standard form, okay? Start with vertex, move it into standard. So let's see here. We're going to start with y equals a times x minus h quantity squared plus k. And they don't tell us anything else, like they don't tell us about a vertical shift. So the a is just an understood one. It has been translated right 3. We're going to do opposite of what we think right is. We're going to take away. We're not going to add. That's a right 3. And then down 2, minus 2. And this is what g of x looks like in vertex form. Now you want standard form. To write an equation in standard form, you're going to take what's squared and you're going to write it twice. But I've been over that. You just have to do it. And don't forget about your minus 2. But first you're going to FOIL, box method, whatever you want. I'm going to FOIL for the video. I'll have x squared minus 3x minus 3x, -3 times -3 plus 9, and then minus 2. And if we combine our like terms, you know, -3x and -3x is 6x. I hope you understand that. And then 9 minus 2 is 7. Easy peasy lemon squeezy, right? All right, 3. Identify the transformations of the mother function f of x equals x squared that result in the equation f of x equals 4x squared plus 8x plus 96. So let's just look right here. This is a. A is 4. What does that tell me? That tells me there is a vertical stretch factor of 4. It has 4 times the initial slope. It grows 4 times as fast. Now, in order to see the rest of this, we need to know what h is. Remember, we need to find h and k. H is going to be your horizontal translation. And it's found using opposite b over twice a. So b is 8, right? B is 8. So it's going to be a -8 over twice a. I'm getting that by looking right here. That's b. This is a. Over twice of 4. That's going to give me -1. What does that mean? That means that I am shifting 1 unit left. All right, to find k, I take that h value and I plug it back in. This is a skill a lot of y'all are not wanting to master, but I'm going to plug that -1 in. Now, you're going to see me do a lot of this by hand because I don't want to pull up the calculator. So, by all means, be a button pusher. There's nothing wrong with that. Push buttons on that exactly as it's written. This is going to create a positive 1. 4 times a positive 1 is 4. Then we have minus 8, and then we have minus 96. If we take 4 and negative 8 and put them together, we have a negative 4. And negative 4 minus 96 is negative 100. So we shifted 1 unit left, but what does this mean? This means down 100 units. That's what it means. All right. Now on the next one, I'm going to have to pull up my TI-84 to do it. I'll write some stuff out next to it for you to play along with. And you do need to play along. You do not need to be listening to this thing muted, all that good stuff. All right, now, what are we supposed to do here? Find the equation of a function that fits the points below. So we're going to click on, as we do this, we're going to go to Stat. We're going to choose Edit. The X's into List 1. The Y's into List 2. And you're supposed to use quadratic regression, so then we're going to press Stat, Calc, Quad Reg. Now, find and interpret R. I'll talk about that in a second, but to find and interpret R, what you're going to press is you're going to press second 0. You're going to scroll to Diagnostics On, and then you're just going to turn it on. Now, the deal with R is, if R is close to 1, it's perfect. It's a really good regression. If R is close to 0, it's a bad one. Like, that's really all there is to it. All right, so let's see if we can crash my laptop. All right. Stat, Edit. I've got stuff in here, so I have to clear it. On test day, yours will be cleared. I'll make sure they're cleared. All right, my X's are -2, 0, 2, and 4. My Y's are 20.4, 5.4. 21.7 and 32. Yeah. Typos. And 32.6. All right, from here we're going to go to Stat. We're going to scroll on over to Calc. We're going to do a quadratic regression. Now this calculator probably already has diagnostics on, but I'll walk you through how to turn it on. And there I go. So let's go out to 4 decimal places. 1.6188x squared. Y equals 1.6188x squared, because a goes in front of x squared, minus 0.5925x, and then plus 10.905. Now you'll see that mine has an r value. It actually has an r squared value. It says that r squared equals 0.8204. I had to write that down because I'm going to see what the square root of that is. Square root, it's actually going to be bigger. You take the square root of a number between 0 and 1, you get a bigger number. That's how it works. I figured that out when I was like 5. 0.9058. And this is close to 1. So what we have is we have a strong quadratic relationship. So we have a strong quadratic relationship. Now, how do you get the R value? I told you earlier that you're going to hit second 0, and you're going to scroll to diagnostics on, and you'll have to turn this on. If you want the point, you got to turn this on. But I'm just hitting that down arrow until I see diagnostics on. It's going to take a while, especially with an emulator. Dun, 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 dun. Oh, there's the one that got me in trouble. Remember her? Yeah, it's there. And then you just press enter, and that will give you the R squared value. All right, moving forward. Let's get this out of my way. Maybe. This is why I don't like pulling up the calculator. That's going to be there the rest of the video, isn't it? I don't want it there. Let's get it out of the way. All right. Identify on which intervals the function negative x squared plus 6x plus 16 is positive. So it'd be really cool if you could graph these by hand. You and I both know that that's a shot in the dark. It would be cool. Well, I'm going to do it anyways. Remember, your vertex H is at opposite B over 2A, and A was negative 1. That's a negative 6 over negative 2, which is 3. To find K, we plug it in. And what do we have here? We have 9 plus 18, which is 9, plus 16, which is 25. So it's pretty big. Let's check that. Did that wrong, didn't I? We have a negative 9, plus 18, which is 9, plus 16, which is 25. Okay, it was right. So 1, 2, 3, a whole bunch of tick marks up there. It's 325. Does this thing factor? Let's say it's equal to 0. Probably not. Yeah, it does factor. We're going to divide out the negativity. That's going to give me 0 equals x squared minus 6x minus 16. And it does factor. Takes an x and an x to create x squared. Probably an 8 and a 2. 1 negative, 1 positive, because negative 8 plus 2 is the negative 6 in the middle. So my x-intercepts are going to be at 8, 0. And then negative 2, 0. And I know this is a lot for some of y'all. You just don't like to do things when there's a lot. And I can't help that. I'm the one who tried to get everybody in the state of Tennessee out of this class. All right, so where am I positive? I am positive anywhere along this path. Anywhere along that path right there. And that did not highlight very well, did it? I am positive so long as the x values are stuck between negative 2 and 8. So if I like set builder notation, all values of x such that x is stuck between those two things. If I like my interval notation, it's not that bad. It's simply parentheses negative 2 comma 8, and that is the interval in interval notation. Move that out of the way so you can see it. All right, now, there is, as much as I don't want to use a calculator on this one, it's worth talking about. It is. Because some of you guys, bless you, you just can't do a whole lot. But anyways, I could have typed in the original equation, negative x to the second, plus 6x, but you got to play along, plus 16, and then done a zoom 6. And a zoom 6 probably would have been good enough. You wouldn't have seen the entire graph, but surely you could have figured out that I'm above 0, I'm positive, between x values of negative 2 and 8, and you could have figured that out by looking at the graph. All right, number 7, we got a function. She's defined by x squared plus x plus 2. Find all of these things, right? Find them all. What do we have first? We have the domain. I'm recording. Is it urgent? Let me pause this. Be right there. All right, so before I was interrupted, I think I was getting to number 6. Write the quotient 34 divided by 5 plus 2i in the form a plus or bi. So what we're going to do is we're going to take our 34 over 5 plus 2i, and we're going to multiply the numerator and denominator by the conjugate of 5 plus 2i. And the conjugate of 5 plus 2i, we just change the sign on the imaginary piece as 5 minus 2i. So both the numerator and denominator get multiplied through by the conjugate. And the top's easy. You don't need the box method for the top. 34 times 5 is 170. And 34 times negative 2 would be minus 68i. Now, if you want to do the box on the bottom, you can. Some kids do the box, some kids do FOIL. But it's really up to you. I'll do the box method for you. Yep, couldn't see that, now could you? So anyways, we got 5 plus 2i, and we got 5 minus 2i, conjugates of each other. 5 times 5 being 25, 5 times negative 2i is negative 10i. Positive 2i times a negative 2i is negative 4i squared. Remember that one. 2i times 5 is 10i. And you'll see that these two cancel each other out. Now, you need to remember that I squared is negative 1. Memorization, it's such a big deal nowadays. But if you take a negative 4 and you multiply it by a negative 1, you get positive 4. So the only like things that are left are 25 and 4. And that, boys and girls, last I checked, was 29. So they're both over 29. Now, break it apart into its two distinct numbers. Remember, we talk about this in the form a plus bi. So we have 170 over 29. Take away, because there's a takeaway, 68i over 29. And my gut says those numbers do not reduce. So therefore, that problem is done. All right, moving on to number 7. 7 of many. I think there's 22 on this twin. There's several. I may not be able to finish this till tomorrow morning. A function is defined by the equation y equals x squared plus x plus 2. Find its domain. If you miss a domain on a quadratic, and that is a quadratic because it says x squared plus, something wrong with you, and you need to fix that, but something wrong with you. The domain of any quadratic that we're going to study in Tennessee in Algebra 2, unless it's like an honors Algebra 2 class, or real honors 2 algebra class, not what we call honors, is that. The range, this thing is in standard form, and because it's in standard form, well, actually, let me take that back. Because it's in standard form, you're going to have to do opposite b over 2a. You really need a graph, is what you need to some degree. So we're going to go ahead and graph. Our vertex here, h, which we have to do anyways. I do vertex form, so may as well. H is found by doing opposite b over 2a. So b is 1. We'd have a negative 1. A is 1, twice a 1, we get back a negative 1/2. To find k, we plug that thing in. We take a negative 1/2, it says squared, right? You see where it says squared? And then we have plus x, so plus a negative 1/2, and then plus 2. So, you know, I realize that a lot of y'all would struggle doing that math. Like, I get it. You can push buttons, but you have a fourth minus a half plus a 2. A fourth minus a half is a negative quarter. If you add 2, you're sitting at 1.75 as a decimal. If you like fractions, which would be cool if you did, you'd be 7/4. And I know you don't believe me, so... And I should probably check myself. I'm not perfect. So let's pull up the old TI-84 here and see what she says. So what do we have? I'm going to use the storage feature. Let's make that bigger where you can see it. I'm going to take a negative 1 over 2, store it to x, type in the original function, which was x to the second plus x plus 2. Play along, by the way. If you're a button pusher, learn how to push buttons. Back is a fraction. We hit math. We press enter twice. Enter, enter. And there we go, 7/4. Now, by the way, when you looked at this thing right here, A was 1. The vertex form herself is y equals a times x minus h quantity squared plus k. So A was 1. Ones in mathematics are understood. I found h to be a negative 1/2. If I take away a negative, I get a positive. Just don't forget the square, plus 7/4. Now, how does that help me figure out the range? Well, some of you caught on to this and some of you haven't. If I was to graph this thing, I would go left to half, and then I would rise almost 2. The parabola would open up. That vertex is at 1/2, 7/4. So that means that I'm rising from 7/4 all the way up to infinity on either side of the parabola. So my range here, 7/4, comma, infinity, and you can actually get that from the equation. You just have to think about how it opens. That's why I'm drawing, because some of y'all don't realize how things open. I knew it opened up because A was 1. It was positive, so it had to open up. But if you haven't gotten that far, you know, whatever. Maybe you'll get there. All right. Step 4 was the function's minimum. Well, that is that part of the parabola right here where y is 1/4. Or sorry, not 1/4, 7/4. It is literally y equals 7/4. It is the y value of the vertex. All right. Now, could you use a calculator to help you with this? To some degree, you could. You really could. All right, so, and I'm not knocking it. I want y'all to do well. Of course, my guess is most of you by now have already fast forwarded. You're on to the second problem. Because truth is, you don't care to learn the material. You want a certain grade, but you don't want to put in what it takes. I'm not wrong about this. Everything is there. If I want to know the vertex, I could hit second trace. I could have chosen 3 for a minimum, which, by the way, is what this thing asks. It asks for a minimum value. I get left and I press enter. I get right and I press enter. And then I press enter for a guess. And there she is. There's your negative 1/2, and there's your 1.75, just like I told you. And I could have used that information to write my range. I could have used this information to write vertex form because it would have given me h and k. And I could have looked at the graph and figured out domain. There's a lot of things I could have done with TI-84. Anywho, moving forward. Let's get this calculator out of the way. There we go. Minimize her. And let's move on to the next page. Page 2. Don't want that there. The glitches. Solve x squared plus 3x plus 4 equals 0 using the quadratic formula. I guess I'll need that calculator, so I'll leave it up there. Hopefully you know the quadratic formula because I have zero intentions of giving it to you. It is x equals negative b plus or minus square root. X equals negative b plus or minus square root. B squared minus 4ac all over 2a. And you just got to pick out your numbers, right, kids? So looking at my equation, I know that a is 1 because it's the understood number in front of x squared. I know that b is 3, and I know that c is 4. And I'm just going to plug stuff in. This one's probably not going to be a very pretty example because it doesn't look like it factors. So plugging in, opposite of a positive 3 is a negative 3, plus or minus square root. I've told you it is good practice to wrap that in parentheses. And then minus 4 times 1 times 4. And it's all sitting pretty over twice a, and a is 1. So 2 times 1. Now, some of y'all doing the math is going to be pretty rough. It is, we both know that. That's how you do that. So do not be the kid who types in the entire radical. I'm pretty sure there's going to be like a negative 7 in there, but we'll see. Notice I typed in exactly as I wrote. I saw a kid the other day using the actual multiplier. Use parentheses, bro. There's a -7 in there. So x equals -3 plus or minus the root of -7, both pieces over 2. Now, the root of -7 is not real, right? That's not real. So what we do is we make it imaginary, and then we change it to a +7, and they're both over 2. And there's your two answers. One of your answers is 3/2 plus the imaginary root of 7 over 2, and your other one is 3/2 minus the imaginary root of 7 over 2. And there's your two answers. All right, moving on, we got a vandalist. A vandalist throws paint balloons. Why is it there? I don't want it there. Go away. Can I trash it? Will that close it? A little worried about what happens if I do that. A vandalist throws paint balloons at cars during rush hour in downtown Memphis. The balloons are thrown with an initial acceleration of 48 feet per second from an initial height of 6 feet. Of course, this is not the true setup. The true quadratic equations are a little past y'all's ability right now. From initial height of 6 feet. Using the form, height as a function of time is -16t squared plus the initial velocity plus the initial height, write an equation modeling this act of vandalism. And, you know, I'd love to say that everybody's going to get this particular part right, but they're not. Kids are going to pick weird things. There's nothing I can do about that. It's your attention span, not mine. The velocity is given as 48, so 48 for there. And the initial height is given as 6. That's how hard that problem is. Part 2 is will the balloon, not is it going to, will the balloon reach a height of 40 feet? So we're going to take that 40 and we're going to plug it in on the left. And you're not actually asked to solve for the times. It's a will situation. Notice it says will. This is about the discriminant. That's what it's about. We're going to go ahead and just take 40 away from everything. So 0 equals -16t squared plus 48t minus 34. Now, the discriminant, b squared minus 4ac, if it's equal to 0 or greater than 0, has real solutions. Put an S there in parentheses, because if it's equal to 0, you have 1 repeated. If it's bigger than 0, you have 2 real. So this is just a will question. So we're just going to figure out what b squared minus 4ac is. So we're going to do 48 squared minus 4 times a times c, and this has a chance at being imaginary. I don't think it's going to happen. But let's find out, right? We got 48 that's squared minus 4 times a negative. The reason I say it's imaginary is because I know that a negative times a negative times a negative is a negative. I feel like it might be. Oh no, it's 128. End up being positive. So because I'm greater than 0, I can say yes. There are 2 solutions. That's kind of surprising to me that that actually became true. But it worked out that way. I didn't think it would. I thought after the initial second it would start falling back, but apparently it doesn't. Any sign mistakes in the TI-84? Doesn't look like it. No mistakes in my math. All right, so yeah, there's 2 solutions according to that math. So, you know, if you think about what's going on here, you got your little vandalist throwing paintball balloons, and the paint balloon ball goes up and goes down. The reason there's 2 solutions is because it hits that 40 foot on the way up and the way down. All right. Get this out of the way. It came right back, didn't it? All right. Assuming the paint balloon hits a lifted truck's fender, which is 4 feet above the ground, how many seconds will it take after the vandal releases the balloon to hit the truck? I actually have zero intentions of you doing this particular problem by hand. In fact, you could have kind of cheated your way through part 2. But I want to know when the height of the balloon is 4 foot. So I'm going to set 4 equal to the equation. You're going to get 2 non-real answers if you do this one by hand. And we are going to just look at a TI-84 on this one. That's part of the class. Part of the class is learning how to use technology. So let's go to y equals. We'll put a 4 in y1. We'll put a negative 16x to the second plus 48x plus 6 into y2. I'm not going to make you do the quadratic formula on this one. I don't think it will work out nicely. And then we're going to hit zoom 6. So here you'll see the 4 foot. I don't know how much the quadratic we're going to see. We saw enough. So I want to know when it hits 6 feet. You're probably going to have a negative answer here. Second trace 5 for intersect. There should be a negative answer here that doesn't make any sense. You just get close, you press enter 3 times. And that's a negative time, which is extraneous. I didn't want you to do the quadratic formula here because, well, it's a test and you only have so much time. Get close, press enter once, twice, thrice. Here's the other one. It's roughly 3.04 seconds. So the time is about 3.04 seconds. Again, make sure you're playing along in a calculator. Like watching me, and I've told this every group for 15 years, but nobody ever believes me. Watching me is not enough. I don't care what your name is. I don't care if you think your stuff don't stink, because it does. You've got to play along. Plain and simple. All right, let's pause real quick, and then I'll be right back. And I'm back. All right, given that f of x is 4x squared plus b of x minus 12 equals 0, what value of b will cause the equation to have one real repeated solution? So you do have to memorize some stuff. This happens, and here's that memorization words. It happens when b squared minus 4ac is equal to 0. That's when it happens. So looking at your equation here, a is 4, b is oddly enough b, right? And then c is negative 12. We're just going to plug into that little form. We're going to see what we get back. So everywhere I see a b and b squared minus 4ac, I'm still a b squared minus 4 times a, which is 4, and then times c, which is negative 12. And remember, the deal is it has to equal 0. I've got to figure out what negative 4 times negative 12 is. I know it's positive, so this has probably got imaginary solutions, which means nothing. Make sure I didn't do any mistakes. All right, so 4 times 4 is 16 times negative 12 is going to be, sorry, negative 16 times negative 12 is positive 192. And oddly enough, it doesn't look like you can make this thing do it. Now, does it? So we would have b squared equal to negative 192, which means that b is plus or minus the imaginary root of 192. And what we just learned here is that there are no ways this can happen. For some reason, that is very surprising to me. But the math is mathing. I don't see a single mistake. So there is no b value that creates one unique solution. Apparently there is no way to turn that into a perfect square. Kind of surprising to me. I'm really shocked by that. But it is what it is. All right, what value of b will cause the equation to have 2 real unique solutions? Here the situation is that you're greater than or equal to 0. So b squared minus 4ac must be greater than or equal to 0. And we've already done most of the math. Oh, I don't like this equation. Too bad I've already made copies of this thing. That stinks. That really stinks that I've made 2 copies of this thing. And it's not going to have any real unicular solutions because we're going to have the same thing here. B squared plus 192 equals 0. And that's going to give me b squared equals negative 192. And there is no value of b that creates real solutions. At least not a real one. Something has got to be wrong. Let me pause this. This just seems so wrong. Well, I don't know if it's me, but I have an issue with this problem the way it's laid out, but the math ain't wrong. So go with it. Something seems off to me. Sometimes it takes a second set of eyes to catch a mistake, and I don't think I made one. I'm going with it. All right, what value b will cause the equation to have solutions that are complex conjugates of each other? So this one is also kind of going to have the same problem. Apparently there aren't any. Like, I am just blown away at the issue with this problem. Hopefully the one on the bonus twin is better. But this again happens when b squared minus 4ac is less than 0. So b, looking back up above, was still b minus 4 times a, which was still 4, times c, which was negative 12. Still less than 0. And we still have the same issue here. So maybe it's just a bad problem. We're going to have positive 192 greater than 0. And what we're going to get here is that b squared must be less than negative 192, which is not something that you can answer with real numbers. So there are no values. So again, there are no b values. Bad example apparently. I would make sure to look at the bonus twin on this one, because that's evidently a very horrible example. Sorry about that. Wish I had time to make a new one, but I don't. I already gave all the papers out. Definitely look at the bonus twin on that one. Maybe it's a better example. All right, moving on to page 3 of 6. Of course, the 6th page I'll do on the tablet that I use. Determine the number of real solutions of the following systems. The idea here is, in a perfect world, you'd be a good grapher. Now, you're not, but in a perfect world, you can knock these things out like that, because you know how to graph. X squared plus 5, 1, 2, 3, 4, 5. It has an initial slope of 1. It looks like that. Negative x plus 2 crosses the y-axis at 2. Falls 1, runs 1. Looks like that. These are mental problems for, sadly, a select few individuals. B, x squared plus 2 and 2x plus 4. Again, this is a shift up 2, 1, 2, just like the other one. We have an initial slope of 1. We rise 1 both ways. And then we have 2x plus 4, which will cross the y-axis at 4. And then it will rise 2 and run 1. And what you can see is it's going to have 2 solutions. All right, then we have negative x squared minus 12 and x plus 3. That is going to be a parabola that opens down. And it's going to fall 1 and run 1 both ways, because we learned our lesson on initial slope. But again, like I said, this is sadly something that seems to be lost to the current generation. Even y equals x plus 3, I don't know what y'all's issue with the thing is. It crosses the y-axis at 3, and it has a slope of 1. I don't know what kind of rock you've been living under, but man, quit being a Patrick. Patrick is off SpongeBob. He lives under a rock. He's dumb, kids. No solutions. Because there's no way those two things are going to intersect. Now, for those of you that are living under a rock, how did Milbrath come up with those graphs? Well, I'll do the last one with you. in a calculator. I'm telling you, like, if you know that math is going to be your thing, don't use this calculator unless you absolutely have to, because it's going to hurt you long run. It is. Technology is great, but it strips away the levels of understanding that you can have. Anywho, Zoom 6, and you're not going to see anything on this one except maybe y equals x plus 3, because the parabola is way down here, right at negative 12. And if you want to see them both, just to know that the drawing that I gave you was right, you go to your window. I'm going to set my y max to be something like my y min to be something like negative 20. And that's going to let me look farther down the axis. Again, you should play along if you are playing along. And that should make it more apparent here that there's no way on God's green earth that these two things are going to cross path, hence no solution. Okie dokie, Smokey. Moving on to the next one. Solve the linear quadratic system using the substitution property. It doesn't look like a bad one, and I honestly doubt on the test I would do a bad one. You guys are working in class today on that worksheet, and I did not make that worksheet. I usually make most of your stuff, but evidently I was out of time when I made that one. And it came straight from your textbook, which is just horrible. As much as people like to complain, if I just assign problems out of a book, this class would be way worse. Now, notice that both of these are solved for y. It does say using a substitution property. So we're going to take this x plus 4 and we're going to put it right here. It's going to give us a line that says x plus 4 equals negative x squared plus 6. And if we have a quadratic, 99 and 100 times what we do is we set the thing equal to 0. So I'm going to jump equality, and if I jump equality, I change my sign. The x was already on the left, so plus x, 4 minus 6 is negative 2. And now I've got a 0 on the right-hand side, and hey, it's factoring. That's all it is. It's a factoring problem. You know, what's it take to make an x squared? Well, it takes an x and it takes an x. What's it take to make a 2? It takes a 1 and it takes a 2. I want to add to 1, so plus 2 minus 1. Still equal to 0. A lot of kids, and you'll see this, even dual enrollment kids, pre-calc kids, they'll do the factoring and then they'll do something stupid like saying x is 1 or x is 2. It's not, because you got to use ZPP, zero product property. X minus 1 is 0 or x plus 2 is 0. And it's not that they don't know, they're just making careless mistakes. I am guilty of it myself from time to time. But there's your two x values. X is 1 or x is negative 2. Now, we're going to use substitution again. I'm going to go after this equation right here. It's an easy one. If x is 1, y is 1 plus 4, which is 5. So my order of pair here was 1, comma, 5. If x is negative 2, y would be negative 2 plus 4, which is 2. So I get the order pair negative 2, 2. And if we looked at a graph on a TI-84, those would be the answers. And by the way, I said notice that. That was a test hint. If I looked at the graph on a TI-84 and used the intersection feature, maybe I could get the answers, you dum-dum. Use it. Unless you're going to be a STEM major. If you're going to be a STEM major, don't use the calculator. Unless you have to. If you're taking the class after this, which is either dual enrollment or pre-calc, I highly encourage you to learn as much as you can by hand. All right, solve the equation using the graphing ability of your TI-84. And for notes here, for some of you who need to take notes, you're going to place the left-hand side into y1. You're going to place the right-hand side into y2. You're going to do a zoom 6, which is standard, and then hopefully you're going to hit second trace intersect. And that's if and only if you don't have to play with the window. So we'll see what happens after a zoom 6. All right, so play along, boys and girls, if that is your pronoun. I have no idea. Negative 3x plus 4. Yeah, what's the other one? 2x squared plus 2x minus 4. Ah, come back here. Okay, there she is. What was she again? I think she was 2x to the second plus 2x minus 4. Anywho, so I'm right here now, zoom 6. This is probably not going to be something with pretty answers. I think if it's on a test, I probably don't want you to play with your window. Because, you know, I'm just looking, oh, but of course this is a twin. We are going to have to do a window adjustment. You see there's an intersection up here somewhere, up high. So we're going to go to window. We're going to change the Y max. Let's try 20, see if it's enough. You just guess your way through these things. Eventually you kind of get a good idea of what to push. 20 looks like it's enough. We shall find out. Alright, then we hit second, trace, 5. We get close to the cursor. I hit the wrong thing. Second, trace, 5 for intersect. We get close to the intersection. I always go after the left one first because that's how we read left to right. Press enter, enter, enter. Negative 3.6085. And the Y value is 14.8255. There's one answer. Back through the process here. Second, trace 5. Get close. Press enter 3 times. And here's the other one, 1.1085. And 0.6745. Ta-da! All right. What do we got next? We got another one of these, use the quadratic formula. So for the second time in this video, I shall sing to you because I know you just love hearing it. And if you don't know the quadratic formula by Friday, that's not a Milbrath problem, that's a you problem. Just sing this darn song. It goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. I have kids come back years after years. They might be nursing majors or whatever. They say, Milbrath, thank you for singing. You're welcome. Anyways, a is 1, b is negative 6, c is negative 5. X equals negative b, so I'd make that a 6 plus or minus square root. Always wrap it in parentheses. B squared minus 4ac all over 2a. And a was 1. So let's see here, let's do some math here. We got a 6 plus or minus. You can push buttons on this if you want, but that's 36 plus 20, a root of 56, and everything is over a 2. Root 56 does simplify. It does. Root 56 is going to be a root of 4 times what? 14? Times a root of 14, which is 2 square roots of 14. Alright, so let's do some simplification here. We have the 6 over the 2 plus or minus the 2 roots of 14 over 2. And 6 over 2 is 3. The 2's cancel. We get root 14. So our two answers are 3 plus a root of 14, or, by the way, it's x equals 3 minus the root of 14. Awesome. All right, what's up next on our little agenda here? It looks like it's a complete the square problem. That's not going to go so hot. It's not. I wish it would, but it's not. I've got 11 minutes. I think I'm going to be working during lunch break to get this one done. And I've still got another one. Your bonus twin I'll probably just do on my tablet I have because it takes a lot. It's just a lot quicker. Doesn't look as flashy, but it's a heck of a lot quicker. Yeah, I'm going to stop on this page because I just realized that a couple of y'all from 5th period never came back and finished your basics quiz. If you put an eye on something, you have to have it finished before class the next day. I don't know what kind of elementary, middle school mentality we're stuck in, but this is high school kids. Grow up. All right, so we're supposed to complete the square. I'm not going to worry about the 10 because the 10 is allowed to be on the other side anyways, but I do need to divide everything by 2. That's going to give me x squared minus 4x equal to a 5. Notice I leave some space, just model things the way Milbrath does. Now off the side, I'm going to take half of b. I'm going to cut it in half, and I'm going to get a negative 2. That tells me that this will ultimately factor as x minus 2 squared. But before I can actually do that step properly, I have to take the negative 2 and I have to square her, and that'll give me 4. And that, boys and girls, has to be added to both sides. That'll give me 9 on the right. See? Now this works because if I think about how this actually factors, takes an x and an x, and of course a lot of y'all can't factor to save yourself. Factors of 4 are 2 and negative 2, and to add to negative 4, they're both negative. Now, moving forward, the opposite of squaring is simply to take square roots. So I have something squared on the left, I can counter that out with a square root. Do not forget plus or minus. The root of 9 is going to be plus or minus a 3. And if you take a square and you square root it, you get the contents inside. So x minus 2 equals plus or minus a 3. Add 2 to both sides and do a little arithmetic and you're done. X is 2 plus 3, or x is 2 minus 3. Now 2 plus 3 is a 5. 2 minus 3 is a negative 1, and those are your x values. All right, we got some factoring up next. Factor x squared minus 25. There is no equal symbol, so do not solve. It doesn't say equals anything, it just says factor. And these are your go with your guts. These are what we call a difference of two square patterns. So when you see numbers that you can take square roots of, if you can take the square roots of them, do it. It's probably right. To create a 4x squared, your gut should say 2x and 2x. To create a 25, your gut should say 5 and 5. And I've done this with y'all before. Think about plus, that's a plus, no x. These things need to knock each other out of the park. So one's negative, one's positive. 17, you know, that's not anything special. 17 is brute force factoring. And doesn't say solve, it's just brute force factoring. There's lots of ways of making a 15x squared. You could be a 1 times a 15, or you could be a 3 times a 5, and the teacher, which is me, usually picks on things that are closest to each other. That's what I do. So I'm going to suggest that it's probably going to take a 3x and a 5x to create your 15x to the second. And now what I'm going to do is I'm going to focus on the factors of 8. I could be 1 times 8, or I could be 2 times 4. Now whatever I do, I want to add to 14. So it's probably the 2 and the 4. I feel like it is. Of course, we'll check it. It's guess and then check it. 4 and 2. The outside is going to make 6x, and the inside is going to make 20x. And your goal here is to get this positive 14. So the 20 is positive and the 6 is negative, because 20 minus 6 is 14. And the issue you guys have with factoring is your addition and subtraction are weak, and your ability to multiply is even weaker. And again, it says do not solve. Let me try and get another one of these done, because I don't have a lot of time during lunch break to finish things. And it looks like those are kind of lengthy. As much as I need to grade some stuff for 5th period, I need to do more of this right now. And, you know, that's another thing, kids. When you can't do things in a timely manner, it's not just you that you're impacting, it's me. And I'm not going to sit here and hold your stuff for days and days and days. I gave you the benefit of a doubt. 5th period starts in 5 minutes. Nobody came to make anything up. A line passed through the points, negative 1, 4, and 2, 8. What is its equation? Y equals mx plus b form. Here you're going to need a couple of things. You're going to need slope for one. And every 7th grader knows the formula for slope is y minus y1, or y2 minus y1 over x2 minus x1. But can juniors do it? No. Can sophomores do it? No. Can freshmen do it? No. I don't know what's wrong with you. The top is 8 minus 4. The bottom is 2 take away a negative 1. And that's going to give me 4/3. Now, I'm going to use this form that I've done with y'all. It's y equals a times x minus h plus k. You've got your slope. We just figured out to be 4/3. I expect this question to have about a 50% success rate. And I can use any one of these 2 points for x for h and k. I'm just going to go with the first one because the numbers are smaller. Okay? So plus 1, because it's minus, and then plus k, which is 4. And then I'm going to hit it with that distributive property. Y would be. I noticed a lot of kids on the last quiz could not distribute a fraction. 1 times anything is the anything. 4/3 times 1 is 4/3. And you're holding TI-84s. Like, if you do not know what 4/3 plus 4 is, first off, God bless you. Secondly, figure it out. Thirdly, you had a TI-84. Watch this. Watch. I just don't understand what happens to kids. Push the buttons, man. Math. Enta. 16/3. Y equals 4/3 of x plus 16/3. And that's where I'm going to stop. So I'll finish this video hopefully during my lunch break. Hope you had fun. Alright, I should be back. Hopefully it's doing everything right. 19 is solve the inequality 4x squared plus 1 being less than 3x plus 2 using the graphing ability of your TI-84. So obviously you're going to grab your TI-84, right? And what you're going to do is you're going to place the left-hand side into y1. And I'm going to be drawing, and you should too, because the drawing is part of it. And I also can't just have the camera up and explain it. And you may need to be drawing too to fully comprehend. Your hands have memory. They do. They have memory. So use that aspect. And hopefully it'll help this stuff stick. Alright, so I got my TI-84 up. On the right-hand side, we have 4x squared plus 1. So that's going to go into y1. Now what do we have on the right-hand side? 3x plus 2. We're going to do a zoom 6 the way I've been telling y'all to do things. Hit zoom 6. And here's our inequality. I wish I was on my board because I could just take a snipe of this and steal it. But I'm not. I'm going to find the intersections real quick. Second trace 5, intersect. I can't remember if I made these numbers come out nice or not. So I got negative 0.25 and 1.25. I got to write that down for myself here. And the other set of intersections looks to me like it's something a little over 1. It's probably like 1.25. These things usually have some degree of symmetry. Could be 1.75. Maybe it's just 1. Get close. Enter, enter, enter. Oh, it is. It's at 1.5. Now let me do a rough drawing here for y'all. It's also for me. This guy was 3x plus 2, crosses at 2, then rises 3 and runs 1. That was your line. Your parabola will cross the y-axis at 1, and then it will have a slope of 4, rise 4, run 1. Not really a big deal that you know that, but it kind of is. I may have missed something. Crosses at 1, then rises 4, runs 1. I missed those points there pretty bad. And what we wanted here were our 2 intersections because they determine things. So that was at negative 0.25, comma 1.25, and the other one was at 1.5. Now, let's think about shading here. It's asking, and this is kind of the tough part on understanding what these questions are asking. What are these things asking us to do? And I know it's tough. Every math teacher who teaches this subject knows it's tough. And it's back. Hadn't quite mastered using a calculator on this new board yet. What I'm asking here is, where is the parabola below the line? You see the less than symbol? It's where is the parabola below the line? That's the question. This is your solution space, because that's where the parabola is below the line. And you know, the other hard part about this is what x values make this true. I'm going to have to speed up. I only have so many minutes of lunch break here. Well, an x value that's stuck between negative 0.25 and 1 make this true. That's a 1 comma. So x is stuck between negative 0.25 and 1. And that's how you answer this thing. Of course, you couldn't read that. Let me move my text out a little bit so you can read it. See, I don't see the text on the glass. I just see what I write. All right, number 20 is an old problem. Hopefully we have some luck on it this time. What is the equation of a parabola in factored form with x-intercepts of negative 7, 0 and 3, 0 that passes through a point? This one, of course, right now I just got done with 5th period, so I'm thinking about 5th period. You know, there are only 3 kids in 5th period who got this right on the test. And it just is what it is. All day long, probably 40%. We're going to use a form a times x minus p times x minus q. Of course, we can extend this where these two guys are your x-intercepts slash zeros. So when I look at my point, I've got a p and I've got a q. So I can now write that y is some leading coefficient a times x plus 7 times x minus 3. And now I just have to figure out what a is. I hope I can get some more of y'all to do this time. This gives me an x and a y. Everywhere I see a y, I get to become 3. And everywhere I see an x, I get to become negative 1. So 3 equals a times negative 1 plus 7 times negative 1 minus 3. Negative 1 plus 7, last I checked, was 6. Negative 1 times 3 is negative 4. Still have an a. And if we do 6 times a negative 4, we're going to get negative 24. So 3 equals negative 24a. Divide out the negative 24, and we will have our a value. You know, you can push buttons all you want in a calculator. This tells you that a is negative 1/8. Now, you're going to have to pick out the correct equation. For the equation, all you got to do is put that thing right there. So when we talk about your equation, it's y equals f of x, g of x, whatever, negative 1/8 of x plus 7 times x minus 3. I'm not asking you to write this thing in STD form. I just want that. All right, the last two up here are graphs. And I warned you that you're going to have to learn how to do graphing. Your test will obviously not be as long as this twin is. It won't be. I'm not going to let you use it. I'm not. So maybe you can figure some stuff out. The one you're given is in what we call a vertex form. It's in the form a times x minus h plus k. Specifically, it's x minus h quantity squared plus k. So I know that my vertex is at positive 3, 7. And that's a good place to start, right? One, 2, 3. And then rise 7. 1, 2, 3, 4, 5, 6, 7. It's right there. Now, there are other little things that I can use for my assistance. Remember that this 3 is your initial slope. So as I move to the left and right 1, I would rise 3 more. There's things I want you to find. The y-intercept is one of them, and that's easy. For a y-intercept, we just let x be 0. So it's 3 times a 0 minus a 3 squared, add 7. And then we do math. This is a negative 3. If you square negative 3, you get 9. times 3 is 27, right? 9 times 3 is 27. Add 7 again, I think you're at 34, which is literally going to be off my grid, isn't it? It's going to be somewhere up there, but it's 34. Ordered pairs are wonderful. That's 0, 34. Based on what you've looked at so far, when you talk about your x-intercepts, they do not exist. There are no x-intercepts because that thing opens up. And of course you got the vertex. I've got things off here, don't I? X-intercept was DNE. Oh no! X-intercept does not exist. Your vertex was at 3, 7, if I remember right. And the line of symmetry passes right through that vertex. So the line of symmetry is x equals 3. All right, last one. Hopefully this thing did not quit recording because I just had a power flash. It'd be a disaster if it did. On 22, I am giving you the equation in good old standard form. So you still have to remember some things. Like opposite b over 2a should be stuck in your head by now. Heck, it's part of the quadratic formula. X equals negative b all over 2a. It's part of it. So that's a good place to start. We're going to start by finding h. And h is negative b over 2a. So it looks to me like b is 6. So opposite of that is a negative 6. It's over a twice a. 2 times 3. That's going to be negative 6 over 6, which is negative 1. To find k, we are going to plug that in. 3 times a negative 1 squared. And that works because we have x. If we want y, we plug it in. That is so 8th grade. It is. They've been doing that with y'all for so long. And then we just do math. If you take a negative 1 and you square, you get 1. 1 times 3 is 3. 6 times negative 1 is negative 6. Add 10. 3 minus 6 is negative 3. If you add 10, you get 7. So my vertex was at negative 1 comma 7. And I have no idea if it's going to make a lick of difference making you guys do this all year long or not, but we're going to try. We are. To find a y-intercept, we let x be 0. And we're just going to plug into our equation. 3 times a 0 squared plus 6 zeros plus 10 is 10. So we have a y-intercept at 0, comma 10. Easy peasy. To find an x-intercept, we let y equal 0. I don't know if this one's got one or not. I think maybe it does, maybe no. I don't think it does actually. Let's plot what we have. Let's see, what do we have? Assuming Milbrath did all his math right. We have a vertex at negative 1, 7. Line of symmetry passes right through there, by the way. So it's x equals negative 1. We have a y-intercept at 0, 10. 8, 9, 10. Ah, nope. It's by symmetry, 1 over here. There are no x-intercepts. It's DNE. Look at your graph, by the way. And that's 22. Now, if the one on the quiz has x-intercepts, it will factor. It will not be something that's too hard. It will factor. It will be small. And it'll factor, and hopefully everybody can do that. So anyways, there is the last of this. Hope you enjoyed the new board. It is slower. That's one of the things I don't like. There you go. There's your first twin.